let's do another compound inequality with a slightly different answer. So let's say we had this the inequality x is greater than 2 or x is less than or equal to 5, which is sort of similar. The only difference is that these two sets actually have some overlap. And let's just kind of discuss, well, what would happen. So again, to begin, what you could do is you could graph them separately. And as I said, when it's or, you could just graph them both on top of each other, because or is a joining operation. We're going to be taking the union of those two sets. So if I was to draw those on top of each other on the same number line, I would have x is greater than 2, which would be taking 2, open circle, shading to the right. And then I would take 5 as my other point, which is over here, and put a closed circle on it and shade to the left. And notice that when I actually put those together, actually the entire number line becomes shaded, because when these two sets have some overlap and they're going in opposite directions, it becomes the entire real number line, or often, as we say, that would be all real numbers, because it's the full number line. And so basically, I mean, you could still write it like this, because I have all numbers from 2 to infinity, or is written by union, and then I have all numbers less than 5, including 5. So I could take the original two solutions and just write them using the union joining notation. But my point here is there's actually a way of simplifying this response. Over here, I couldn't simplify it because they were totally separate. But when they're put together, as I can see above, these two join into all real numbers, which we often write as from negative infinity to infinity, meaning everything. And like how no answers has the special symbol of the null set, all real numbers has a special symbol, which we often refer to as script R, meaning everything. So if you're wondering, well, what's the right answer? Well, all of these mean the same thing, but this is a simpler way of writing this. And it takes a little bit of recognition based on, well, how do I know that? And again, that's where the graph comes in handy, so I can really visualize that it's really everything from negative infinity to infinity. Now, let's say we were to look at the same example, but use an intersection instead of a union, because again, we get an even different answer once again. And as I said, when we're using and, it means the set of answers is the set of solutions to each inequality which is in both. It's going to be the overlap, and instead of just joining them together, we're going to be looking at where they have commonalities, which in this case there was no overlap, there was no commonalities, which is why my intersected set had nothing. But when I'm intersecting sets that do have something in common, again, what I recommend doing first is drawing each set on top of each other, not on top of each other like in the last one. Basically put both sets on top of each other in two different number lines. So x is greater than 2, here's 0, open circle shaded to the right. And then in my second number line, I have x is less than 5, which would be a solid circle on 5, shade to the left. And when I look at like this, when I'm trying to find where it's in this one and in this one, I can see based on the overlap on where the sets, what numbers do they have in common. Like the first set has all numbers bigger than 2, the second set has all numbers less than 5, including 5. And those two sets have some numbers which are in both. Whereas over here, there were no numbers that were in both, which is why we got nada. And over here, we just have all numbers between 2 and 5 would be in our intersection. And notice that since 2 is not in the first set, it wouldn't be in the intersection, because it has to be both greater than 2 and less than 5. And 2 is not greater than 2. But even though 2 is in this set, it has to be in both, but 2 is not in both. Whereas 5 would be included in this answer, because 5 is included in both, right? Because 5 is shaded here and it's shaded here, because 5 is greater than 2 and 5 is less than or equal to 5. And that's why it makes sense, because all of these are the answers that are in that one and in that one. And so anyways, we tend to get an inequality sandwich in here. And this is kind of like how I mentioned that a triple inequality is actually the same as a compound inequality. We could actually rewrite this inequality like this. 2 is less than x is less than or equal to 5. Because notice that this sandwiches all of our solutions between 2 and 5, not including 2, but including 5. And this is actually exactly an equivalent way of writing this compound inequality using the sandwich notation. Now, this notation is more common, but at the end of the day, it's synonymous. It means the same thing. And we'll do more practice in class this week, as well as elaborating on absolute value inequalities, how it plays back into all this. Anyways, that will be it for this little mini lecture series.